For almost 46 years, this squat device resembling a gigantic space loudspeaker has been transmitting astonishing data from its pearly white conical disk. In addition to being the furthest human-made object ever, it had several other notable accomplishments, such as the first craft to reach interstellar space, the discovery of new moons orbiting Jupiter, the identification of yet another ring around Saturn, and the creation of the first family portrait of our solar system. Featuring our diverse group of planets, Voyager 1 and its twin, Voyager 2, set out on a cosmic adventure in 1977 and are currently exploring the solar system's outer regions. Now, with some prodding, researchers have picked up an unexpected cryptic communication from far outside our solar system. This is quite shocking and saddening. So why are the scientists working on the Voyager mission bracing for disaster? Join us as we uncover the cryptic message from the depth of the solar system, sent by the Voyager probe. Voyager 1's communication needs to be addressed, and NASA engineers might have discovered a brilliant technique to achieve it. The probe has been transmitting jumbled data since November, indicating its advanced age. A poke to the weathered probe elicited an unexpected reaction from the engineers. Due to its advanced years, Voyager 1 has begun improvising, which makes its messages extremely cryptic. Despite setbacks, engineers from NASA have persisted in extracting the data. The response to the NASA engineers' request contained an unexpected data set. Perhaps this is the one thing that can unlock the mystery of the spacecraft's signal. Since their launch in the late 1970s, the Voyager 1 and Voyager 2 spacecraft have been continuously transmitting data regarding our cosmos. Nobody anticipated their longevity beyond 5 years. Thus, they continue to astound with their engineering prowess. However, they have outlived their lifespan by more than 9 times while still transmitting data about the universe. Being the sole spacecraft to have explored interstellar space, Voyager 1 and Voyager 2 occupy special places in the annals of space exploration. The Voyager 2 probe 6 years ago made history when it formally entered interstellar space after leaving the solar system. It was the second human-made object to do this. Voyager 2 was launched on August 20th, 1977, 16 days before its twin Voyager 1, which exited the solar system's northern hemisphere in 2012. Voyager 2 was sent on a longer journey that allowed it to make encounters with Uranus and Neptune. To this day, it's the only spacecraft to have visited these planets up close. It then made for the southern hemisphere of the heliosphere, the outermost region of the solar system, straight for interstellar space. Crossing the heliopause, the border between the heliosphere and interstellar space, on November 5th, 2018, Voyager 2 formally exited the solar system. This occurred at a distance of 119 astronomical units from the Sun, where an astronomical unit is approximately equal to 93 million miles, roughly the distance that separates Earth from the Sun. The spacecraft examines solar winds, plasma particle composition and behavior, cosmic ray interaction, magnetic field structure and direction, and other features that characterize the solar system's periphery. Unexpected events occurred during Voyager 2's departure from the bubble. The data showed that the bubble was very leaky. Material from the solar bubble was discovered in interstellar space. Additionally, Voyager 1 had discovered indications of a bubble that was leaking. Contrary to what Voyager 2 found, interstellar material was actually found rushing into the bubble on that occasion. New evidence shows that the heliopause's leakiness is not an isolated bubble feature, as observed in 2 distinct regions of the heliosphere. Nonetheless, the source of this phenomenon remains unknown. They were also surprised by how uniform the bubble's boundary is. Scientists had previously hypothesized that as one moved farther and farther from the Sun, The solar bubble would gradually dissipate into interstellar space, a theory that the Voyager missions tested. In fact, there's a very, very sharp boundary there. As it turned out, the plasma wave instrument on Voyager 2 measured plasma densities that were quite similar to what Voyager 1 found. As you go across the boundary between solar plasma and interstellar plasma, the density of the plasma increases by a factor of 20 to 50. This is a common occurrence in fluids as they frequently create sharp boundaries. Particularly surprising to scientists was the fact that the two Voyagers passed through the heliopause at identical relative distances, 121 and 119 AU respectively. An increase in solar activity during Voyager 1's 2012 crossing was supposed to have pushed the bubble's perimeter farther out, according to previous models. The heliopause should have been slightly farther back during Voyager 2's crossing last year due to a period of low solar activity. For the time being, it is unclear why the two spacecraft departed the solar system at about the same distance from two separate sites. Several findings from Voyager 2 don't match up with a clear border, at least not in the way we would expect. The measurements of the magnetic fields both within and outside the bubble are the most significant of these. It was anticipated by astronomers that the two would have drastically differing magnetic field directions. Lead author Leonard Berlage of NASA's Goddard Space Flight Center notes that Voyager 2 and Voyager 1 both saw that there was essentially no change in the direction of the field when they crossed this thin surface. Also, according to Voyager 2's magnetic field measurements, the heliopause it encountered was narrower and less complex than the one Voyager 1 had crossed, and it was loaded with less energetic particles. The cumulative effect of all this information is to pose more problems than it solves. Coronal mass ejections, or CMEs, are plasma shock waves ejected from the Sun that have a significant impact on the solar system as a whole. It turns out that the Sun's influence extends well beyond its own area. The new Voyager 2 data, similar to the previous Voyager 1 data, demonstrates how CMEs go across the heliopause and reduce the cosmic ray flux outside the bubble. The information is comparable to what could be found in space. CME supernovae shake the interstellar medium by sending shock waves out into the galaxy, but on a far grander scale. A supernova's interstellar shock wave initiated the development of our solar system, according to most astronomers. These results provide credence to the theory that the Sun may impact the evolution of life on other planets in our solar system and beyond, especially when considering the possibility that cosmic rays may cause biological mutations on Earth. According to Stone, the space age was only 20 years old when the Voyagers were launched. It was difficult to comprehend at the time that anything could endure for 4 decades. In any case, the heliopause observations constitute a last-ditch effort by both spacecraft. Plutonium-238 heats radioisotope thermoelectric generators, which power each probe. The substance is decomposing on its own. The possibility that there won't be enough electricity to run scientific equipment for another 5 years or so is something that Stone acknowledges. According to Stone, we believe every star has these features, and the 2 missions will provide further information about the Sun's heliosphere interactions with the interstellar medium. The knowledge we gain regarding this heliosphere will pave the way for further exploration of stellar atmospheres. While scientists at several U.S. institutions are responsible for collecting data from the Voyager probes and communicating with them, the real work of turning this data into valuable scientific insights is being done by scientists at NASA. Every day, the distance between Earth and each spaceship continues to increase beyond 10 billion miles. Although the spacecraft's instruments are showing signs of age, NASA has found creative ways to get data from them. This method has revealed previously unseen details about the universe beyond our solar system. That's what's most important, is keeping these spacecraft operating as long as possible, stated Suzanne Dodd, NASA's project manager for Voyager, in January. When the telemetry modulation unit of the flight data system started transmitting a repeated sequence of code on November 14th, 2023, the mission crew initially discovered the communication issue with Voyager 1. Gathered from the spacecraft's scientific sensors and combined with engineering data, Voyager 1's flight data system provides an accurate picture of the spacecraft's present health. The information is sent to Mission Control on Earth in binary code, which is a system of numbers. However, Voyager 1's flight data system has been inoperable since November. Although the spacecraft is still capable of receiving and executing mission crew commands, Voyager 1's scientific and engineering data was not relayed to Earth due to an issue with the telecoms unit. The mission crew has been trying to transmit commands to restart the computer system and get to the bottom of the problem ever since they found it. In the event that a problem was to blame, the team transmitted an order to Voyager 1 on March 1st, known as a poke, to instruct the flight data system to execute other software sequences. The crew discovered on March 3rd that among the jumbled data, there was activity emanating from a specific area of the flight data system. An engineer from NASA's Deep Space Network deciphered the signal, even though it wasn't in the usual format that the Voyager crew uses when the flight data system is working as it should. Antennas on Earth form the Deep Space Network, which allows the agency to interact with spacecraft like the Voyager Probes and others in the solar system. According to an update released by NASA, the decoded signal includes a readout of the whole memory of the flight data system. The memory of the flight data system contains both the code and variables that can be changed in response to commands or the status of the spacecraft. Data pertaining to downlink science or engineering is also included. As a first step towards identifying the cause of the problem, the team will compare this readout to the one that was generated prior to the problem. They will search for differences in the code and variables. Due to the spacecraft's great distance from Earth, orders transmitted from Earth take 22.5 hours to reach Voyager 1. On top of that, they have to wait 45 hours to hear back. After starting the decoding procedure on March 7th and finding the readout 3 days later, the team is currently analyzing Voyager 1's memory readout. Using that information to devise a potential solution and attempt to put it into action will take time, according to the space agency. The last time Voyager 1 experienced a similar but not identical issue with the flight data system was in 1981, and the current problem does not appear to be connected to other glitches the spacecraft has experienced in recent years. Voyager 2 lost contact with Earth for 7 months in 2020, among other unforeseen problems and dropouts that have befallen both spacecraft over the years. When a command accidentally turned Voyager 2's antenna in the wrong direction in August 2023, the mission team resorted to a last-ditch shout method to get in touch with the spaceship. The problem with the Voyager 1 data is not shocking. This is, however, just the most recent problem with the probe systems that NASA has had to resolve. Professionals are worried that the probes are nearing the end of their useful life due to the frequency of breakdown. It seems, nevertheless, that NASA has figured it out. The Flight Data Subsystem, FDS, is one of 3 onboard computers that bundle the data before transmitting it to Earth. And engineers realized that this was likely where Voyager 1's problem lay. The ping to the Flight Data Subsystem on March 1st returned a mostly muddled signal on March 3rd, but it contained some data that differed from the rest of the computer's unreadable data stream. One NASA engineer with the Deep Space Network decoded this precious signal, unlocking a readout of the FDS's memory that contains instructions and variables the engineers can use to understand what went wrong. This doesn't mean all is saved. The team is analyzing the readout, using that information to devise a potential solution, and attempt to put it into action will take time, according to NASA. The last missions of the probes will go on regardless of the outcome. Even when they can no longer communicate with Earth, Voyager 1 and Voyager 2 will continue to drift through the galaxy, carrying golden records with information about humanity. The hope is that these could act as interstellar messages for potential intelligent life that may intercept the iconic spacecraft. Would it be a mistake, though, for the Voyager spacecraft to broadcast Earth coordinates? According to the science fiction novel Battlefield Earth by L. Ron Hubbard, the answer is yes. In the novel, the Cyclo invaders consider Earth part of a rim star system, way out on the edge of a galaxy in the 16th universe. This was the last universe to be discovered by their race and was never wholly mapped. Without the Voyager probes, Earth could have been forgotten about. The Cyclos, on the other hand, invaded Earth after finding gold disks within. They gassed the planet to kill out most of the inhabitants and then began mining the planet for gold and other minerals, all in the name of banking, interstellar mining, and regular matters for the Cyclos. In their view, the intergalactic rights belonged to them, and they could conquer entire galaxies and planets with the power of gold. As the Voyager spacecraft traveled away from Earth and into interstellar space, they carried a special message for anyone who'd find them in the far future. The Voyager Golden Record containing songs, images, and sounds of Earth. It was designed to be an information-laden cosmic time capsule, capable of being easily deciphered by any intelligent alien species to come upon it. On the cover of the record, a series of diagrams was emblazoned, including one very important one: a map of Earth's location in the galaxy. The record includes images, scientific information written in a universal language, greetings in 55 languages, a collection of music, and a message from the then President of the United States, Jimmy Carter. Their message will remain with both spacecraft as they continue to drift for billions of miles, hoping to be discovered by an intelligent spacefaring culture. Some others say it's risky to publicly broadcast our precise location, given what we know about the galaxy and the potential number of inhabited planets. The outcome may be hostile extraterrestrials similar to the Cyclos from Battlefield Earth. While the original approach to pinpoint Earth's location was brilliant, its inherent flaws have already been revealed. So anybody getting it will likely not be able to pinpoint our planet's exact location. Having a reference frame is crucial for determining the location of our sun in the galaxy, since the stars are constantly moving relative to one another. Even on very short time scales, the appearance of our night sky can alter dramatically. The genuinely brightest stars, which are furthest away, could have been mapped out, but then they could have collapsed into black holes, or died in supernovae without any notice. A pulsar map was instead chosen. The 14 distinct pulsars' relative orientations, distances, and pulse timing frequencies are inscribed on the Voyager Golden Records, which can be found all around the galaxy. Pulsars, which are thousands of light years distant, are among the most precise and trustworthy cosmic clocks, the data for which is also included on the Pioneer 10 and 11 missions. The stars' relative positions will shift as they move across the Milky Way, but their pulse frequencies and approximations of where they are in relation to the Sun will be easy to spot for tens of millions of years. By tracking the changes in those two variables over time, we can not only pinpoint the exact location of Earth and the Sun, but also determine the exact launch dates of those space probes. Pulsars are neutron stars that spin at incredibly high speeds. Their fast rotation, which can approach 65% the speed of light, and the charged particles on their surfaces produce the greatest magnetic fields in the universe, with strengths that are trillions or quadrillions of times stronger than Earth's. These powerful fields generate electromagnetic radiation by accelerating charged particles in their immediate surroundings. Any object in the neutron star's radiation field's path gets a pulse whenever the star finishes a rotation. Pulsars are the ones that point in our direction. The concept appeared to be a solid one, as these 14 objects that were identified to generate an Earth-finding map are pulsars. While some find the approach to map construction to be ingenious, others argue that it is fundamentally faulty because the map will become obsolete due to long-term changes in space. Perhaps by the time someone does discover it, they will face an incredibly cryptic puzzle. However, the truth remains that the probes from the Voyager spacecraft are still out there. The map is still out there, the code is still up in the air, and an alien race may invade Earth at any moment in a manner similar to that of Battlefield Earth. Is sending out a chart of Earth's coordinates a mistake? It would be some time before we find out.